Assalamu alaikum wa rahmatullah. Today we will start with chapter 16, Polynomials, part 5. Our objectives are: specify whether a certain value of the variable is a root of a polynomial, simplify a rational expression to the simplest possible form, solve an equation of the form p in x over q in x equal to 0, where p in x and q in x are two polynomials in x and q in x different from 0. We need the following materials: textbook, draft papers, pen, and calculator. Root of a polynomial. A real number a is said to be a root of the polynomial p in x if and only if p of a equal to 0. Remark: p in x is a polynomial and a is a real number. To calculate p of a is to replace x by a in the polynomial. Example: given p in x equal to 3x squared minus 2x plus 5, calculate p of minus 2. Solution: to calculate p of minus 2 is to replace x by minus 2 in the polynomial. So it becomes p of minus 2 instead of p in x. Equal, we replace x squared by minus 2 squared and x by minus 2. So it becomes 3 into minus 2 squared minus 2 into minus 2 plus 5. Here we calculate according to the order of priority. Powers, multiplication, addition, and subtraction. After calculation, it gives 21. So p of minus 2 equal 21. Example 1. Given the polynomial p in x equal to x squared minus 5x plus 3, are the numbers 3 over 2 and 3 roots of p in x? Solution: we replace x by 3 over 2, so we get 2 into 3 over 2 squared minus 5 into 3 over 2 plus 3. We replace x squared by 3 over 2 squared and x by 3 over 2. After calculation, the answer is 0. As p of 3 over 2 equals 0, then 3 over 2 is a root of p in x. P of 3, we replace x by 3, so we get 2 into 3 squared minus 5 into 3 plus 3. We calculate it, the answer is 6, which is different from 0. As p of 3 different from 0, then 3 is not a root of p in x. Example 2. Given the polynomial q in x equal 4x squared minus 9, find the roots of q in x. Here pay attention. To find the roots of q in x is to find the solutions of the equation q in x equals 0. Solution: q in x equals 0, then for x squared minus 9 equal to 0. Here we have equation of the second degree since we have x squared. So to solve this equation, we must factorize it. It is of the form a squared minus b squared, which gives a minus b into a plus b. So the factored form is 2x minus 3 into 2x plus 3 equal to 0. Here we have product of two factors equal to 0. Then either the first factor to x minus 3 equal to 0 or the second factor to x plus 3 equal to 0. We solve the first equation to x minus 3 equals 0 to x equal 3, which gives x equal 3 over 2. And then we solve the second equation to x plus 3 equal to 0, then to x equal minus 3, which gives x equal minus 3 over 2. Then 3 over 2 and minus 3 over 2 are the roots of q in x. Application. Consider the two polynomials a in x and b in x. Part 1. Verify that radical 2 minus 1 is a root of a in x. Part 2. Factorize b in x, then calculate its roots. Please pause the video and try to solve it. Solution. Part 1. To verify that radical 2 minus 1 is a root of a in x, we replace x by radical 2 minus 1, so it becomes a of radical 2 minus 1. And then we replace x squared by radical 2 minus 1 squared, and minus radical 2 into x by minus radical 2 into radical 2 minus 1. Now we need to expand it. We have radical 2 minus 1 perfect square. It is of the form a minus b perfect square, which gives a square minus 2ab plus b square. And then we multiply minus radical 2 by radical 2 to give minus 2, and minus radical 2 by minus 1 to get plus radical 2. Then we need to simplify it. We simplify plus 2 radical 2 with minus 2 radical 2, plus 2 with minus 2, and then plus 1 by minus 1, and the answer is 0. Then radical 2 minus 1 is a root of a in x. Part 2, we need to factorize. We have here for x squared minus 1, we can write it as 2x perfect square minus 1 square. So it is of the form a square minus b square, which gives 2x minus 1 into 2x plus 1, where a is 2x and b is 1. And then we take a common factor to x minus 1. After we take the common factor to x minus 1, we divide 2x minus 1 into 2x plus 1 by 2x minus 1 to get 2x plus 1. and then we divide minus into 2x minus 1 into 5x plus 2 by the common factor 2x minus 1 to get minus into 5x plus 2, and then we reduce inside the bracket, and the answer is 2x minus 1 into minus 3x minus 1. Here we can take minus as a common, and the answer will minus into 2x minus 1 into 3x plus 1. Then, to calculate the roots, we put b in x equal to 0. And then we write the factored form of b in x equal to 0. Here we have product of two factors equal to 0, either the first factor equal to 0 or the second factor equal to 0. We solve the first equation, minus into 2x minus 1 equal to 0, which gives x equal 1 over 2, and then we solve 3x plus 1 equal to 0, which gives x equal minus 1 over 3. So 1 over 2 and minus 1 over 3 are the roots of b in x. Now, rational expressions. Domain of definition and simplification of a rational expression. A rational algebraic expression can be written as the quotient of two polynomials. A rational expression of the form p in x over q in x, where p in x and q in x are two polynomials, is defined for q in x different from 0. Since it is a fractional expression, so the denominator must be different from 0. Example 1. For what values of x is f of x equal to x plus 1 over x plus 3 into 2x minus 5 defined? Solution. F of x is defined for x plus 3 into 2x minus 5 different from 0. Since it is a fractional expression, the denominator must be different from 0, which gives x plus 3 different from 0 and 2x minus 5 different from 0. Then x different from minus 3 and x different from 5 over 2. Example 2. Simplify g in x equal x squared minus 3x over x squared minus 9. Step 1. Factorize. So we must factorize the numerator and the denominator. By factorizing the numerator, we have x a common factor. So we take x and then we divide x squared by x to get x, and then minus 3x by x to get minus 3. In the denominator we have x squared minus 9. It is of the form a squared minus b squared. So it gives x minus 3 into x plus 3, where x is a and 3 is b. Step 2. Find the domain of definition. G in x is defined for x minus 3 into x plus 3 different from 0. Since we have here a fractional expression, is defined when the denominator different from 0. So x different from 3 and x different from minus 3. Step 3. Simplify. We write g in x in the factored form, and then we have x minus 3 as a common factor between the numerator and denominator, so we can simplify x minus 3 by x minus 3 to get the answer x over x plus 3, the simplest form. Application. Determine the domain of definition of f of x, then simplify. Please pause the video and try to solve it. Solution. Part 1. F of x equal x squared minus 36 over x minus 6 into 2x plus 5. Step 1. We must factorize. Here we have x squared minus 36. It can be written as x squared minus 6 squared. So it is of the form a squared minus b squared, which gives x minus 6 into x plus 6. In the denominator we have product between two factors, so it is written in the factored form. Step 2. We give the domain of definition. F of x is defined for x minus 6 into 2x plus 5 different from 0. Since it is a fractional expression, it is defined when the denominator different from 0, which gives x minus 6 different from 0 and 2x plus 5 different from 0. Then x different from 6 and x different from minus 5 over 2. Step 3. We must simplify. So we write f of x in the factored form, and then we have x minus 6 as a common factor between the numerator and the denominator. So we simplify x minus 6 by x minus 6 to get x plus 6 over 2x plus 5. Part 2. F of x equal 5x into 3x minus 1 over 9x squared minus 6x plus 1. Step 1. We must factorize. In the numerator we have product between two factors, so it is written in the factored form. But in the denominator we can write it as 3x perfect square minus 2 into 3x into 1 plus 1 square, which gives 3x minus 1 perfect square in the form a minus b perfect square. Step 2, we give the domain of definition. F of x is defined for 3x minus 1 perfect square different from 0. So 3x minus 1 different from 0, which gives x different from 1 over 3. Step 3, we simplify. So we write it in the factored form, and then we simplify the numerator and denominator by 3x minus 1 to get 5x over 3x minus 1. Rational expressions and equations. Example, solve the following equation for x squared minus 9 over 2x plus 3 into 5x plus 1 equal 1 over 2. Step 1, factorize and find the domain of definition of the rational expression. Here we have for x squared minus 9, it is of the form a squared minus b squared, which gives 2x minus 3 into 2x plus 3. But in the denominator we have product between two factors, so it is written in the factored form. And then we give the domain of definition. This fraction is defined for 2x plus 3 into 5x plus 1 different from 0, so x different from minus 3 over 2 and x different from minus 1 over 5. Step 2, simplify the rational expression. We put the factored form, and then we have 2x plus 3 as a common factor between the numerator and denominator. So we must simplify the numerator and denominator by 2x plus 3 to get 2x minus 3 over 5x plus 1. Step 3, solve 2x minus 3 over 5x plus 1 equal 1 over 2. Pay attention here, we put the simplest form equal to 1 over 2. And then, since we have equal between the two fractions, then we can make a cross product. So 2 times 2x minus 3 equal 1 times 5x plus 1. And then 2 times 2x we get for x, 2 times minus 3 we get minus 6. Here we have an equation, so we isolate x. We have minus x equal to 7, so x equal minus 7. Step 4, check if the solution is accepted. Minus 7 different from minus 3 over 2. And minus 7 different from minus 1 over 5. Thus, x equal minus 7 is accepted. Application. Solve the following equations. Please pause the video and try to solve it. Solution. Part 1. Step 1. Factorize. In the numerator we have product between two factors, so it is written in the factored form. But in the denominator we have x squared minus 49. It can be written as x squared minus 7 squared, which gives x minus 7 into x plus 7. This fraction is defined for the denominator different from 0. That is, x minus 7 into x plus 7 different from 0, so x different from 7 and x different from minus 7. Step 2, simplify. We put it in the factored form, and then we have x minus 7 as a common factor between the numerator and the denominator. So we simplify both by x minus 7 to get 3x over x plus 7. Step 3, solve 3x over x plus 7 equal 3 over 2. We have equal between the two fractions, so we make a cross multiplication. Then we get 6x equal 3x plus 21. We isolate x to get 3x equal 21. So x equal 21 over 3, x equals 7. It is rejected since x different from 7 in the domain. Thus, the equation 3x into x minus 7 over x squared minus 49 equals 3 over 2 has no solution. Part 2. In the numerator we have product between two factors, so it is written in the factored form. But in the denominator we have 25x squared plus 30x plus 9. It can be written as 5x perfect square plus 2 times 5x times 3 plus 3 squared. Its factored form is 5x plus 3 perfect square. So in step 1 we write the factored form, and then we must give the domain of definition. This fraction is defined for the denominator different from 0. So 5x plus 3 perfect square different from 0, then 5x plus 3 different from 0, which gives x different from minus 3 over 5. Step 2, simplify. We put the factored form, and here we have 5x plus 3 as a common factor between the numerator and denominator. So we simplify both by 5x plus 3 to get to x minus 3 over 5x plus 3. Step 3. Solve to x minus 3 over 5x plus 3 equal to 0. The rule is if we have a over b equal to 0, then a equal to 0 because b different from 0. Then to x minus 3 equal to 0, which gives x equals 3 over 2. It is accepted since it is different from minus 3 over 5. Thus, 3 over 2 is the solution of the equation. This is your homework, and this is the summary of our lesson. Thank you for watching. Wassalamu alaikum wa rahmatullahi wa barakatuh.